Okay, so sorry the last video just got cut off, but what I was just gonna say is that that's why we have a total of 3,889. But when you put in your formula, make sure that your z-score number is changed and just do the same kind of calculations, you know, just do the timesing and then the adding, and that should be it. Okay, so we're gonna go on to number 5. An unknown distribution, oh, I'm sorry, let me say again that we're doing the central limit theorem homework. And again, this is for Math 115. Okay, so we got number 5. An unknown distribution has a mean of 12. See, I just stop right there. Once I see those kinds of clues, I'm writing mean of 12. Okay. And a standard deviation of 1. Standard deviation of 1. Okay. A sample size of 25 is taken. Sample size, we know whether you put, I mean, you can put X, you can put N. I'm putting 25. I'll just put N because it just tells me the count. Let X equal the object of interest, which means that sample size could mean X, BX, but I'm not putting it. Anyway, what is the mean of the sum of X? What is the mean of it? So the way we're gonna figure this out is, let me move. Okay, so we've got, what is the mean of let's see, we got this formula. Why can't it work? Mean of the sum of X equals the count, the mean, and X. Okay, so basically what we're going to take is the count. The count is 25. Times it by the mean, which is 12. Times it by the, mx, right? So those two are just it. That's it. Just times those two together, and we've got 300. Because m, right? The mean is, but the mean sample is basically the same thing. Okay, so that's it. Just 300. Easy as that. Right? We got it. Okay, sorry, let me view that. 300. Okay. True or false? This is number 6. True or false? Only the sums of normal distributions are also normal distributions. Okay, false. The sums of any distributions approach a normal distribution as the sample size increases. Okay, I'm sorry, I'm not sure if everybody got a good view. The mean of the sum of X, right? So that was just the count times the mean. The count times the mean. That's all you needed. Okay. What 3 things must you know about a distribution to find the probability of sums? Okay, so the probability of sums was the sample size. You need the sample size, the standard deviation, and the mean. Okay. Okay, now I guess I don't have it written anymore, but let's just look at that. The mean, the sample size, the standard deviation. In this particular one, you need the z-score too, but on some of them, it's not required. Number 8. A manufacturer produces 25 pounds lifting weights. Produces 25-pound lifting weights. The lowest actual weight is 24 pounds and the highest is 26 pounds. Each weight is equally likely, so the distribution of weights is uniform. A sample of 100 weights is taken. Let me erase my board. Okay, so yeah, okay, so this one actually I don't have to do any writing. Basically it's just this one here. And that's just by looking at it, the 24.9 and coming down, so that was close to 25, right? And then this one, a manufacturer, it says draw the graph representing the probability that the mean actual weight for the 100 weights is greater than 25.2. And so if it's greater, then the shading would go this way, right? So that's why I chose this one. And that was it. The only one I didn't get was the percentile. So hopefully that helps for the central theorem, limit theorem for the homework. And we'll see if I can do some of the other one, because that one has me guessing. But we'll try to do the continuous probability in this next video.